Okay, this is day 5 geometry, the SAAS, hills, and hala, as a friend of mine calls it. All right, this is all about right triangles and how they kind of mush them together in this idea. Okay, well, first of all, if you remember, and you kind of have to know this, that the longest side in a right triangle is the hypotenuse, and the other two sides are called legs. So if you don't remember that, make sure that you think about that. So those are called legs, and that's the hypotenuse. When we have a triangle and we draw the line down that's perpendicular, that line is called either the height or the altitude. Now we're going to use the word altitude because it starts with an A, and height, the letter H, is already taken with hypotenuse. So we're going to call it the altitude, and that's going to be important for you to remember. Okay, so when I look at these two triangles here, I know that these two triangles are similar because angle A is the same as angle D, angle B is the same as angle E, and if those two angles are equal, these have to be equal up here at the top because they have to add up to 180. So these both have to be, what is that, 45? No, 55? So I know that they have to be similar because all the angles, the pairs, are the same. So the sides are going to be in proportion. And that's easy enough. That's not so bad. We talked about similar triangles and how the sides were in proportion. But what happens if I throw the two, actually now 3 right triangles together? Do you see the 3 right triangles? This right triangle, and then I have this right triangle, and then I have the giant right triangle. And as crazy as it sounds, all 3 of those right triangles are similar. Okay, so and here's why they're similar. So if I talk about this triangle, I'm going to pull it out and put it down here. And this is U. This is a right angle. This is T. And at the top, this is R. And now I'm going to pull out just the giant triangle so that it looks like this. And this is angle R, this is angle T, this is angle S. Well, I already have angle, sorry, not that one, angle U in the little triangle is the same as angle R in the big triangle because they're both right angles. And if I look at the picture, these two triangles share angle T, so angle T must be the same as this angle T, which then angle R up here at the top has to be the same as angle S. So if I were going to name them RTU, for instance, I have to make sure I match up the same angles. And I know that angle R is the same as angle S, angle T is the same as angle T, and angle U here is the same as angle R. So that's great, and then I could talk about similar sides or proportional sides, blah, blah, blah. But it's kind of hard to see all of that when I'm in a triangle. So we talk about hypotenuse, legs, and altitudes. So here's what we're going to do. This side, this line right here, RU, is called the altitude in this picture because it's perpendicular to the opposite side. So that's the altitude. That's going to be the letter A. And then this side here is the big giant hypotenuse, and that's going to be the letter H. This side, RT, is going to be leg, and I'm going to call it leg number 1, or L1. This side over here is a leg, so I'm just going to call it L2 for leg 2. Doesn't matter which one is 1 or 2. And then notice the hypotenuse is divided into 2 parts. So those parts we call S for side. So since this is leg 1 on the left side, I'm going to call that S1 for side 1. And then the one on the right I'm going to call S2 because leg 2 is on the right. Okay, so there they are. Now look, if I go this way, if I go this triangle, the hypotenuse is the giant side, AB, so that's going to be H for hypotenuse. The BC at the bottom here, that's going to be one of the legs, so I just arbitrarily call it leg 1. The AC is also a leg, so I'll call it L2. So that means AD is going to be S2, and DB is going to be S1, and then of course CD is my altitude. That's how we label them. Okay, so now to simplify this, here it is, a whole big picture for you. I tried to draw it on the computer, it's kind of funky. Anyway, this is what we're going to memorize. We're going to memorize SAAS, HLLS, and HLLA. So we don't have to worry about which sides, blah, blah, blah. I'm going to use my SAAS, HLLS, and HLLA. SAAS because S1, A, S2, that's a proportion. And so if I write it like that, I can solve lots of problems. HLLS is H over L1 equals L1 over S1. And I could also use H and use L2, L2, and S2. But that's HLLS. That's what I call it. And then HLLA over here, notice we have L1 and L2 in the middle. Okay, so whenever you have an A in your formula, SAAS or HLLA, you have to make sure you use 1s and 2s. Okay, so how does this work? All right, let's talk about this. We'll try this example. We have an altitude. There it is. Here's my letter A. I'll put it back in red. Here's my letter A for altitude. I'm going to call this one L1. I'm going to call the one over here L2. Does not matter which one is which. This one is S2 because it's L2. This one is S1. And then the whole thing, again, is H. Okay? So now DG is 4. Let me change colors. DG is 4. DG, so that's 4. So that's an S. GE is 8. GE is 8. So that's this. And if I needed to know H, I could do 4 plus 8 would make 12. What's the length of FG? FG is the A. This is what I'm looking for. So I know S1, I know S2, I know H, and I'm looking for A. So which one am I going to use? SAAS, HLLS, or HLLA? Well, I don't know anything about the legs, right? I got no legs. So it can't be HLLS or HLLA, so it has to be SAAS. So S1 over A equals A over S2. So I didn't care about H. H is nice to know, but I don't need to know it. So S1 I've marked as 8. A is unknown. A is unknown. And S2 is 4. So now I cross multiply. A times A is A squared equals 32. So now you have to take the square root of both sides to get the final answer. So A equals, and because we don't really know how to do that yet, we'll just round to the nearest, I don't know, 10th or 100th, whatever. So 5.656. So I'm going to call this 5.7. Okay? That's it. Let's try this one. Now this one they don't give us a picture. It's not very nice of them. So we have to draw our own picture. So it says in right triangle QRS. So I'm going to draw a right triangle. Like that. It says angle R is the right angle. So this is angle R, it's the right angle. So it doesn't really matter which one QRS. It doesn't really matter which side, which other vertex is which. The altitude RT, so that's here, and I'm going to try to draw it as best I can so it looks perpendicular, is drawn to the hypotenuse QS. QR is 20. Oh, and that's a leg, right? QS, ooh, QS is my hypotenuse. Find the length of QT. So that's S1, right? Show how you arrived at your answer. Okay, so how do I find S1? I don't know anything about A. I don't know anything about S2. I don't know anything about L2, so what do I have here? I've got Hills and Hala. Can I use this one? H, L1, L1, S1, Hills? H, L1, L1, S1. Do I have those things? Ooh, I do. So let's plug them in. 25 is H, L1 is 20, 20 again, and then I'm looking for S1. I'm going to put an X. And so then I cross multiply. I get 25x equals 400. So 400 divided by 25 is 16. So x equals 16, which is good because it's got to be less than 25. All right, I'm going to quit now. Maybe if you need more help, I can make some more videos, so let me know. Bye.